in x values delta x, which equals y2 minus y1 all over x2 minus x1. We can determine the average gradient of the curve, where h is the horizontal distance between the 2 points, by drawing a secant through the points with x coordinates of x and x plus h. Did you know that some ancient Romans' homes were fitted with a type of air conditioning? It's true. Some Roman homes had a network of pipes built into the wall so that during the hot summer months, cold aqueduct water could be pumped through these pipes, cooling the interior temperature of the house. This was an effective early form of air conditioning, although it must be noted only the rich elite of ancient Rome could afford it.
Hello, Tenfolders. Welcome to another edition of Tenfold Live. My name is Sibusi. So, and as always, I'm very excited to share with you awesome content on the revision of Mathematics Paper 2 on the show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to Liberty for affording all this opportunity, guys, to share what we're going to be sharing with you. Remember, like we always encourage you, if you haven't done so, go to your app store and look for what we call the Tenfold Education app, packed with a lot of very useful resources. If you're one person who wants knowledge, that will help you build yourself up with all the concepts and all the building blocks so that when you come and watch this program, you're able to follow. We've got great lessons on that app, and you can also use the app to stream this show live and also send questions to us. Remember, like we always tell you on every one of our shows, there's more resources we have for you. Go to WhatsApp, and when you get there, just send us a greeting, guys. We've got past papers, very useful resources that you can use as well to practice as you prepare yourself for the end of the year exam. Beyond that, maybe you're one person who wants to watch videos. We've done lots of shows on all concepts that you can actually think about that you need if you're one person who is interested in acing your exams. So just go to Facebook and find our page. We are Mindset Learn. If you get there, there's awesome videos on YouTube. Basically, it's actually on YouTube. Like those videos, share all those videos with your friends, and encourage as many people, guys, as you know to go there as well and watch those videos. I promise you, they're very good and they will help you to build yourself up, because you learn when you watch what we're doing, and then after, you then apply the concepts to see if you can be able to answer the questions as well. Maybe you can't and you need more help. That's where this show comes in, and we're going to jump into our first question. It is revision. Mathematics Paper 2, you don't want to miss all the excitement that is coming. We'll be looking at questions on trigonometry. We've got lots of questions on data handling. There's questions on analytical geometry. And if you also want to see how to iron out Euclidean geometry, stay tuned, guys. Let's go to our first question. All right. So this one is a question that was sent to us by Khanim Pahlele. It's a question that is based on the concept of trigonometry, one of the most stubborn sections in Mathematics Paper 2. Let's see how do we work with this one. Question 5.1 says, prove without the use of a calculator that cos of 75 degrees plus cos of 15 degrees is as good as the square root of 6 divided by 2. Okay, so what comes to your mind when you see statements such as without the use of a calculator? You must always think special angles. Special angles, grade 12s, very important. You've done them since grade 10. You should know how to work with them. What are special angles? They are 3, 4, 5, 6. 3, 4, 5, 6. 30 degrees, 45 degrees, and 60 degrees. So somehow I need to take these numbers and incorporate them in trying to simplify what we have on the left-hand side until my answer becomes root 6 over 2. So now the big question comes in, and it is, how does 30, 45, and 60 come into the first part, which is cos 75? So what I'm going to do is I'm going to say on the left-hand side, we have cos of 75, okay, adding the cosine of 15 degrees. So the question is, how can I represent 75 degrees using my special angles? And I think you guys will agree with me that the sum of 30 and 45 is indeed going to give you 75 degrees. That means now I'm going to change 75 and I'm going to call it in terms of those two special angles, and then we are going to have the cosine of 45 degrees plus 30 degrees. Of course, when you're adding, it doesn't matter which one you write first. The second part here is asking for the cos of 15. This will be cos of, again, either I'm adding two numbers or I'm subtracting them so that I end up with 15. And I'm sure you guys will agree with me that if I'm looking for 15, I now need to focus on 45 and 60. 60 minus 45, will that give you 15? We don't know that. But I want to use 45 and 30 because I'm very confident. I know that if you use those two, you're going to end up with the number 15. And again, what is motivating me is the fact that if you are dealing with 30 and 45, you're going to have 30s and 45s like we have in our first term. We'll have them again in the second term, and somehow they will then simplify, because in mathematics, we want things to look the same. The more things look the same, the better. So I'm going to write my 15 as the difference between 45 degrees and 30 degrees. Okay, so now we're going to apply our knowledge of compound angles. The compound of cos 45 plus 30 expands as follows. It's cos. So this information, we can obviously get it in our information sheet. We've got cos 45, and then this is going to be the cos of 30. If it's a plus in the middle, the sign changes to a minus, and then you're going to have the sine of 45 degrees multiplied by the sine of 30 degrees. The result I'm looking at definitely comes from the expansion of the first term. This one here expands to what we are looking in that second tray. Now, the second term also requires us to apply the concept of expansion. So what are we going to do for this one? It's the cosine of 45 minus 30. Like we said, the expansion of cos is always cos. So I'm going to have plus cos of 45 times the cosine of 30. If the sign is a minus in the middle, it's going to become plus. And then we'll have the sine of 45 degrees multiplied by the sine of 30 degrees. Like I said once more, this expansion comes from the green tray. So I'm simply going to say this is basically what you end up with. Now, when you look at the expansions we have, there is something interesting about them. You will see that there's something common. The second term of the first tray is the same as the second term from the second tray. So we're going to cancel those because they are exactly identical, but they've got opposite signs. You'll see that the first one here has a minus, but the second one has a plus. So they are basically additive inverses. So it is like sine 45 sine 30 minus sine 45 sine 30. So those two subtract each other out of our expression. And then what remains is two things that are also identical, but they're both positive. Because they're both positive, it means they will sum up to double whatever they are. So cos 45 cos 30 plus another cos 45 cos 30 is just 2 times cos 45 times the cosine of 30 degrees. Now, what do we know about those? Well, we can expand those because we know how to find solutions to cos 45. That is simply the square root of 2 over 2 multiplied by cos of 30. That will be the square root of 3 over 2. Okay? And then once you have this, you will see that 2 cancels 1, 2. They divide each other out. And on the numerator, the stuff on top, the root of 2 times the root of 3 is like square root A times square root B. From algebra, we know we have to just multiply the contents of those roots. So we are going to end up with, on the numerator, the square root of 2 times 3, which is 6. And on the denominator, we have 2. And this is exactly what they wanted us to prove in the question. Root 6 over 2 is the expected solution when you simplify what is on the left. Therefore, the conclusion is what is on the left-hand side is indeed equal to what we have on the right-hand side. Beautiful question, very simple application of compound angles and double angles, and beyond that, we're just going to see how much more we can do in our next question. Okay, so 5.2 says determine the general solution of 1 plus 4 sine squared x minus 5 sine x plus the cosine of 2x equal to 0. Okay, so like I said in the previous question, in math, things work out quite nicely if we can get all of them to look the same. So when I look at this particular equation that I'm having here as I'm trying to find a general solution, what stands out for me is we've got sine squared, we've got sine x But there's a problem with our third term. It is not in terms of sine, that is basically in terms of cos. So the idea here is, can we get all of them to be in terms of sine? If we had more cos's in this question, we will try and change this so that all our terms are either constants and cosines. The idea is we want all of them to be in terms of the single ratio. It doesn't work all the time, but most of the time, that is the idea that we have to engage in this. Now, the double angle of cosine can be expanded in three ways. One version is cos squared x minus the sine square x. The second version is to cos squared x take away 1. And the last version will be 1 minus 2 sine squared x. And all this information is available in the information sheet. Now, of all these three possibilities, which one is the best to choose as the expansion for the double angle of cosine? Like I said, we already have sine squared. We have another sine. So it is wiser for us to choose the version that is in terms of sine, so that the entire question is in terms of sine. So I'll have 1 plus 4 sine squared x, take away 5 sine of x, and then we are adding that expansion, which is 1 minus 2 sine squared x equal to 0. Now, what do you notice when you look at this? We've got friends. We call them like terms. There's 4 sine squares here, and there's 2 of them here. We've got 4 of them. We are taking away 2. So 4 of those guys minus 2 of them will just leave us with only 2 of those guys. Okay, so, and what I'm also thinking in my mind, I'm already writing this in standard quadratic form because it is quadratic. So you start with the square term. After, we follow with the sine x term, 5 sine x, and then the constant. We've got 1. We're adding another 1. 1 plus 1 is 2, and then the answer is supposed to be equal to 0. Now, I'm now looking at a trinomial, a basic trinomial. If you can't factorize this, use a quadratic formula. What will be the important variables? Your a will be 2 here. This will be your a. Your b will be a minus 5, and your c will be a positive 2. So you can still sub this stuff in the quadratic formula. Just remember, what you are solving is not x, but you'll be solving for the sine of x. Those of us who want to fancy factorization, let's have fun. The factors of 2 sine squared, that's actually going to be 2 sine x multiplied by another sine x. Factors of 2 are going to be 2 and 1, but you have to be careful of where you're putting your 2. You need a 2 to sit here and a 1 to sit here. They both need to be negative. Why? I hear somebody ask. Well, for you to get the middle term, which is negative 5, you multiply this 2, which is going to give you minus 1 sine x, and then you multiply this 2, which will give you minus 4. The minus 1 we get here and the minus 4 we get there are going to give us the minus 5 you see as the value of that middle term we have as minus 5 sine of x. So that's the idea we have. This product and this product, when you combine them, they need to produce that middle term that we have over there. Okay, cool. So let's see what will happen now if we continue on this. Let's see what will happen if we continue on that. The question ran away. Come back. Okay, so we are here. All right, so we just needed to get rid of this since we understand why the 2 has to be where we put it and why the 1 has to be where we put it. So now from here, we then going to say, okay, from our first bracket, which is our first factor, we're going to get that sine x is a half. Or from the second factor, we're going to get that sine x is equal to 2. Immediately, once you see this, I think you'll agree with me that we're not going to get a solution here. That part is not applicable because a typical sine graph is a wave that plays between positive 1 and negative 1. You should know this information, guys. The maximum point you can get in a sine graph is positive 2, and the minimum value you can get is negative 1. So we're asking for angles that will give us a value of 2. There's 2 up there. The graph does not get to 2. So this is not going to be a factor that gives us a solution to this problem. So that's why we're saying sine x can't be 2 because the sine graph doesn't get to a value of 2. It's too high. It only peaks between 1 and negative 1. And it doesn't matter how far you take it. You can take it forever and ever until the second coming. It will always play between positive 1 and negative 1. Okay, so that means our solution is only going to come from the first factor. We've got sine of x equals to a half. Let's see what we're going to get from that. You look at the reference angle, which is arc sine half. So arc sine of a half is going to produce 30 degrees. Now we pick the quadrant where sine is a positive. Where is sine positive? According to our cast diagram, we know in the first quad, all of them are positive. In the second quadrant, sine is positive. In the third, tan, and in the fourth is going to be cos. So the quadrants of interest are going to be the quadrants where sine is positive. And it's definitely going to be quad 2, and the other one is going to be from quad 1. That's the quadrant where sine is positive. So I'm just going to say, okay, well, one answer comes from quad 1. Another answer is going to come from quad 2. From quad 1, the reference angle becomes your solution because you can clearly tell 30 degrees is the number in the first quadrant, so it makes sense that x is going to be 30 degrees. And then from the second quadrant, we're going to say x is, we just use 180 minus because these angles are smaller than 180 by some amount. So this is going to be 180 minus 30, which gives you a value of 150 degrees. Now somebody says, but they said general solution. Yes. If we ask for the general solution, it means this is incomplete. You need to add that little factor that says plus k times 360 degrees, even here, plus k times 360 degrees because we're looking for the general solution, plus k times 360. That's the part that makes it general. It's always going to be k times 360 if you are dealing with sine and cos. But if the question was about tan, you will use 180. Remember to tell them that k is the element of all integers. And if you do this, that will be the solution to this problem. It's very simple and quite awesome. As long as you understand how to work with those equations, everything will always work out beautifully. Next question says to us, we need to prove the identity sine 2a divided by 1 plus cos of 2a equals to tan a. So most of the time, grade 12s never know where to begin when you're dealing with identities. Step 1, copy the left-hand side. So my left-hand side, according to this problem, is sine of 2a divided by 1 plus the cosine of 2 times a. Step 2, do whatever you can do. So what can we do here? I'm looking on the numerator at the double angle of sine. And there's only one way of expanding any double angle of sine. And then for the double angle of cos, we're going to have to think about it. So let me expand what is on the numerator because that one is pretty obvious. It's going to be 2 sine of a multiplied by the cosine of a. This information, once more, is available on your information sheet. Now, on the denominator, I've got a 1. I'm going to keep that. Plus, there's my cos 2a over there. So I want to expand that and see what can this be expressed as. Like we said, there are 3 possibilities. Either you call it cos squared x, in this case it's a, so maybe you might want to delete that and make it match whatever we're working with here. It's pretty straightforward stuff. So it can be cos squared a minus sine squared a. If you want, you can call it 2 cos squared a take away 1 or 1 take away 2 sine squared a. Now, more often than not, matrics don't know which one of the 3 to pick. Don't just pick anyone. Look for the one that is going to make sense. Now, if you look on the denominator, I'm sitting with 2 terms. One of them is a 1. So I'm going to choose the one that is going to delete this positive 1 because I'm trying to get to a tan. Remember, grade 12's tan is sine of a divided by cosine of a. You will notice that in the denominator, there's no constant for you to get to cos of a. So I need to somehow get rid of this plus 1. So the only expansion that will delete a plus 1 is the expansion that has a minus 1. So which means this is the best one to choose of all those 3. So that means we are going to rewrite this as 2. Let's just try and get rid of that. Okay, so it's going to be 2 cos squared of a minus 1. And you'll see after doing this, something beautiful happens. That plus 1 over there we'll get rid of that minus 1 over there, which is what I was actually interested in. I don't want any constants. I just want all those constants to disappear. Okay, so now what remains on the numerator, the ones are gone, of course, they will delete each other. And then you will notice that we now end up with 2 sine of A multiplied by the cosine of A. I'm going to do something that not a lot of people do, which is expand that cos squared. So 2 is 2. What is cos squared? It's cos of A multiplied by cos of A. More people can see this, but we are watching Tenfold live. We want to cover everyone who's watching the program. That is why I'm actually expanding and expressing it as cos times cos, so that you will be convinced that the cos and the cos will cancel, leaving us with sine over cos. And we just said sine over cos is actually equal to tan of A. Therefore, the left-hand side does indeed equal to the right-hand side. So this is proven. Last question is asking us to simplify this. So we're going to simplify a reduction situation. Remember, when you're dealing with reduction formulas, you have to check the quadrants you're working at. But most importantly, if the examiner gives you a big number, such as 450, you need to decrease that. How do you deal with a number that is more than 360? You always subtract 360 degrees if the number is too much. What is too much? Any number more than 360. If you come to the second one, you'll see that we've got minus 180. That's also not good enough. If you have these kinds of numbers, you deal with them by upgrading them through adding 360. The only thing that you can add on an angle and not change the effect is 360. You either subtract 360 or you add 360. 23 and 23, I can't do much on them. There's 44. We will deal with that when we get to that. A negative angle, this is an angle that lies in quadrant 4. We'll talk about it once we get to it. So what do we know about what we are sitting with in the first factor? 450 minus 360 gives you 90. So that question is as good as just the sine of 90 degrees. Take away x. The second part, 360 and negative 180, collectively, they'll just give you positive 180. So I'm going to write that as 180 plus of x. That is just a bunch of numbers and trig ratios. I'm going to keep them here for now. We'll deal with them when we get to the denominator. All over. Now there's cos 44. So now my brain tells me something very interesting. We've got 44, which is not a special angle, which means it's a problem. If I must simplify without using a calculator, I must make sure that I get rid of this without using a calculator, of course. So somehow, this number must cancel with other numbers. Now, if you think about 44, you will notice that 90 minus 44 will give you the number 46, which means I can change the cosine of 44 and write it as the sine of 46. So that is equivalent to just sine of 46. Remember, if the number 46 and the number 44 collectively add up to 90, cos and sine are what we call complementary trig ratios. They are core ratios. So the cosine of 90 minus 44 is the same as the sine of that particular angle. So cos 44 changes to sine 46 because 44 and 46 will give you 90 degrees. Sine of negative x lies in quad 4. Remember, on the cast diagram, 0 degrees is here. This is where negative acute angles will lie, in quadrant 4. And if you think about this, we can just keep it there for now. We'll just expand it when we expand the other trig ratios that we've already expressed in simplified compound format. Okay, so sine 90 minus it's 90. 90 means the ratio is going to change to its core ratio. Sine is going to change to the cosine of x. Positive because this is quad 1. 180 plus, that is quadrant 3. In quadrant 3, tan is positive, so we're going to get this to be tan x. I don't know what that is. I'm going to keep it here for now. Remember, if there is something that is a bit confusing, don't let it keep you. Just keep writing. See those that you can simplify. You'll get to the one that is a bit confusing later on. And if you see 46, something interesting happens from that. 46 is double of 23. So that means I can just use the fact that that number can be written as the sine of 2 times 23 degrees, because 23 is going to be 46 if you double it. So it means we're now looking at the expansion of a double angle of sine, which I'm going to expand as 2 sine 23 degrees times cos 23 degrees. It's the expansion of sine. Now, the last one on the denominator is the sine of negative x, and that simplifies to negative sine of x. Okay, so what will happen now? Great things will happen. Sine 23 will cancel sine 23. Cos 23 will cancel cos 23. Cos x will remain. There's my cos x. Times tan x is sine x all over cos x, and the denominator has negative sine, which I can also put as negative sine x over there. You'll notice that everything cancels out. Sine cancels sine, cos cancels cos. We eventually end up with a number -1 as the solution to our problem. It's very basic, not at all complicated. As long as you remember how your trig ratios work, sine divided by cos will always give you tan. If you've got that covered and you also know how to apply your reductions, you always get this information correct. We're coming back with more content. Don't go anywhere. We'll be right back.
No one ever asks why we do the weird things we do. Like, why once is never enough? Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings? At Liberty, we want to know all the weird and wonderful things that make us human. Because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Did you know that in 2011, astronomers discovered a huge cloud of water vapor in space? Searching out a distant quasar, astronomers accidentally discovered a gigantic reservoir of water vapor in space. It is so gigantic that it's estimated to be at least 100,000 times as massive as our Sun and contains over 140 trillion times as much water as all the oceans on Earth combined.
Welcome back, Tenfolders, to a show that is proudly brought to you with lots of love by Liberty. A very special shout out goes out to Liberty and you as well for watching the program. Remember guys, we love you so much. We have a special app for you. If you haven't downloaded the app and you want access to awesome information, Tenfold Education, that's the app you should be looking for. It will help you to build yourself up as you're trying to cover up all those basics that you need so that when you have to write your exams, you are well prepared. Perhaps you're looking for material to prepare yourself. Go to WhatsApp. We've got you covered. Just send us a greeting there. There's decks with a wealth of information, a wealth of resources, and a lot of very exciting, very, very exciting worksheets that will help you to revise as you're obviously trying to make sure that when the finals come, you are absolutely ready. Beyond that, we also have awesome videos on YouTube. Look for the Mindset channel. Like those videos that we have there. Look for specific videos that will also help you as you try to make sure you cover all the things that you find troubling. And if that doesn't work, you just send questions to us, we will deal with them. And one person who has done exactly that is Itumeleng. We're going to jump into Itumeleng's question because on today's program, we are focusing on revising. We're just going to revise paper 2. We want all those sections of paper 2 that you find challenging. Sections such as trigonometry, and one of them is when you have to work with trig functions. So you don't want to miss out on how to handle a question such as this one. All right, so Itumeleng Esther sent us this question, which is awesome. It is question 6, and it reads as follows. It says, In the diagram, the graph of f of x equals to negative 3 sine of x over 2 and g of x equals to 2 cos of x minus 60 degrees are drawn in the interval x between negative 180 and 180. I think t is a turning point of g with p being less than 0. So you'll see if you check the two graphs, we've got the graph of f of x and we also have the graph of g of x, and we were given the equations of these two graphs, and it's always important for you to make sure that you understand which graph is which. How do you find a lot of information that are related to that specific graph that you could be dealing with? Okay. First question says to us, write down the period of f. Okay, period of f. Now, which one is f? F is the graph of negative 3 sine x over 2. So what I'm going to do is I'm going to write it in a way that will help you so that in future, it doesn't matter how the question looks, you'll always be able to solve it. So if f of x is given to us as negative 3, okay, and then they said it is sine of x over 2, and they're asking us for the period, I'm going to write it in this form. It's as good as negative 3 sine of 1 over 2x. So what you have on top and what I have in my second step is the same thing. Now the most important number here is the number 1/2, because there is a formula you can use to work out the period. It is always going to be 360 degrees divided by whatever the coefficient of x you've got in your question. Our coefficient is 1/2, so I have to divide this by 1/2, and then the answer is going to eventually be 720 degrees. So that half is very important. It is always going to be that number. You always divide by it if you want to find the period. One person says, why 360? Well, because the primary period of a sine graph and a cosine graph is 360. So this is always going to be the case if you are dealing with the graph of sine or you're dealing with the graph of cos. So if you are dealing with the graph of tan, it was not going to be 360. So for tan, it's going to be 180 divided by whatever the coefficient of x you are dealing with. So just be mindful of that. Okay. Second question says, write down the range of g of x. Someone asks, what's the key word in the question? Well, the key word is the word range. Now, range is just asking you the space between the maximum and the minimum value in your graph. The graph we are looking for, remember, is the graph of g. So let's go and find out what's the story with the graph of g. We know that the equation of the graph of g of x is this one. It's called 2. And that 2 tells you what we call the amplitude of your graph. It just tells you what the amplitude of the graph is. And this graph is a graph that doesn't have any shift up and down because we don't have a q factor or a q term on the right hand side of that. If we had some weird odd number there, it will imply that the graph has shifted either up or down by whatever the number of units you could have had there as your q. But fortunately, we have nothing here. So that means our graph is just playing between positive 2 and negative 2. It means the highest possible number is 2 and the lowest possible number that the graph can get to, according to this, if you just keep coming here, you're going to get that it actually plays between positive 2 and negative 2. So that's going to be the range. It ranges between y negative 2 and the y value of positive 2 because that's the graph of g that we are interested in. So how do you write that? Okay, so you're going to say range y is the element of square bracket negative 2 up to positive 2. It plays between negative 2 and positive 2. Okay, next question says calculate f of p minus g of p. Now, what is p? P is the x-coordinate of the turning point. Which one? The one that is on the left. According to the question, we were told that there's a turning point on the graph of g. And P is going to be the x-coordinate of that turning point. Now, let's go back and check where the T is. T will have coordinates P and some y value. And according to what we've written so far, I think you'll agree with me that the coordinates are going to be P and negative 2 because we just said the y-coordinate at the smallest possible value of our g graph is going to be -2. Now we want to know, what is this x? What is the x value of the point where the graph is turning, okay? Now, for you to be able to do this, we have to look at the equation that was given to us. According to the examiner, the graph of g is x minus 60 degrees. So you guys have to know that the parent graph of a cosine graph is cos of x. And that graph fluctuates between 1 and -1. And what it looks like is, it looks like this. This is what it looks like. Okay, that's the parent graph of cos. Now, once you start integrating the minus 60 degrees, you are effectively shifting the graph along the x-axis. In which direction? Somebody asks. Well, let's just put it there for everyone to see what is going on. So what you're doing is the 60 will move the graph by 60 degrees to the right because it's the minus. If it was a plus, it was going to move it by 60 degrees to the left. If I expand this graph to the negative part of the x-axis, I was going to get another V looking like shape on the far left. So what do we know about what we have here? This is -90. This graph is supposed to turn at -180. It's going to cut here at -270, and it's going to turn, to get to the maximum at -360. I'm just interested at the turning point. Remember, we're interested at the value where the graph is turning. So it helps to know how the parent graph looks. So if this is the parent graph, the graph of cos of x, the one we're looking at is shifting to the right by 60 degrees. So if you physically take this shape and move it to the right by 60, what are you going to end up with? Let me see if my engineering techniques are going to work. You've got this beautiful looking cosine graph, right? What do you want to do with it? You want to move it. Where? To the right. By how many degrees? By 60. That's how you end up with the graph that they have in our drawing. So everything has moved by 60 degrees to the right. You'll see that on the graph, we were supposed to have a turning point at -180 degrees. But that -180 that we were supposed to have here, it was supposed to be -180, but we are moving it to the right by 60 degrees, which is as good as adding 60. You're going to end up with -120 degrees because everything is just moving to the right by 60 degrees. So that's basically what you end up with. Make sure that you understand that if you have -180 you're expecting, you're moving it 60 to the right, you'll end up with 120, but not positive, negative. So that number there is -120 degrees. So that's the value of P. Come back here, you are looking for calculating the value of f of, so this is just asking for f of -120 minus g of -120. How do you do that? You call your calculator, all right? And then on the graph of f, remember the graph of f was given to us as -3, okay, sine of x over 2, but our x is changing. What is it now? It's changing to the p value, which you know is going to be -120 degrees. We need to take that, subtract g, the cosine graph. What's the formula for the cosine graph? It was given to us as 2 cosine of, they said, x minus 60. But now our x is -120. We need to take away 60 on that. So what's the final answer that we end up with if we do this subtraction? Call this calculator, put your brackets. There's your -3. We're looking for sine. Open bracket, put a fraction. On the numerator, you're looking for -120. On the denominator, you're looking for 2, all right? And then you close bracket. Close for the first the first term. Then you go far right, you'll see we need to subtract something. Open another bracket so there's no confusion. Let's see, backspace, I think I need to just go to the right. Let's see, minus. Okay, it's not writing what I want, so backspace. If I just press the equality sign on this, I'm getting 3 root 3 over 2. You can just type the whole thing in the calculator and get the final answer from that. Okay, Let's see when I press the right hand side part, what do I get when I type 2 cos, open bracket, negative 120, minus 60, close bracket, I'm getting negative 2. So that's basically what you're ending up with. And we expected this as the y value where the cosine graph turns. And then the difference between those two is just simply as good as taking that 3 root 3 that you have over there over 2, and then you're just adding the number that you're looking at, which in this case I see is the same as adding a 2. So it's pretty simple. As long as you know how to substitute the x value on what you're working with, and then you're not making any mistakes with your signs, you're going to end up with the answer that you can round off to 2 decimal places, which is going to be 4.598, which is as good as 4.060. If you're rounding off to 2 decimal places, you can also leave your answer in set form if they ask you to leave your answer in set form. Okay, cool. So that's a very simple question that is asking us to learn how to work with graphs. As long as you know how to shift the graphs around, how to find a period, and how the parent graphs looks. Because more important than anything is the comparison between the shifts that they've done, either left and right or up and down, versus what the parent graph looks like. This is Tenfold Live. There's still more questions coming. Don't go anywhere. We'll be right back.
Did you know that there is an extreme sport called volcano surfing? Also known as volcano boarding, the sport is similar to sandboarding and snowboarding, except that instead of boarding down dunes of sand or snow-covered slopes, enthusiasts of volcano surfing slide down the slopes of volcanoes. Some of the volcanoes surfed are active, and serious bodily harm and even death are real possibilities.
Welcome back Tenfolders. This is Tenfold Live, a show that is proudly brought to you by Liberty, on a show where we are busy doing the revision of Mathematics Paper 2. Remember guys, if you need more questions, you can find them, or even more theory, on the app that we have. This is called the Tenfold Education app. It's packed with questions. It's got theory videos. It's got theory content. You can send questions to us. You can even stream the show live if you are not at home and you want to watch the program, maybe you're somewhere on your phone. If you have the app, you can be able to watch the program live. Remember, like we always encourage you guys, if you go to WhatsApp and you send us a message, there's actually awesome content that we also have here. We'll give you a lot of practice material. There's a lot of resources, such as the questions we're using on the program. Those are the questions that you send to us, and even more stuff. If you go there, there's decks packed with a lot of very awesome content that will also help you as you're practicing and revising for your final exam. Perhaps you're one person who learns more from videos on YouTube. We got you covered. The Mindset Learn channel is a very awesome channel. Like that particular, subscribe to the channel, so when we upload new content all the time, you'll get to see what we have, like the videos, and then encourage more people to also go there to watch these videos. If you're one person who's struggling, of course, like we say, we encourage you to send questions to us. I don't know where you're having challenges. Perhaps you've been trying to go through something and you need an explanation on how to handle this question. On this program, your question will help a lot of people. So the way we answer them, we don't specifically answer the one that you're sending, but we try to expand so that you guys get the concept, but not the solution to that particular question. So it's always about the ideas that are involved in those questions. No one is going to repeat questions. We're not going to repeat them. But the concepts are going to always follow you. So we always want to make sure you understand them. So if you're one person who sent your question, it could be the one we are using. So please keep sending them. And you might also win something. So without any further waste of time, let's go to the next question. This one is a question that is based on Euclidean geometry, a very awesome concept that also always gives us challenges. Without a waste of time, let's go and see what is going on in this question. All right, so question 10 reads as follows. It says in the diagram, O is the center of the circle, PQRS is a cyclic quadrilateral, okay? The tangent through P intersects RS produced at A. OB is perpendicular to PR and PA is perpendicular to AS. Okay, so what I see is those little boxes, like we have one of them also at point A that indicates that those two are perpendicular to each other. The other one is OS is also perpendicular to PR. That means we also have awesome 90s there, and we're obviously going to have 4 of them in total. So if you have a corner like this, it means all those angles that you have over there definitely have to be 90 degrees, because angles on a straight line add up to 180 and angles around a point must add up to 360. Okay, so I'm going to erase that and we're going to try and see how much we can do in this question, because we can all see what's happening. We are happy. One of the most important things that I also mentioned here is the fact that we've got a tangent, so we're also happy to have that as part of what is going on here. Okay, first question is asking us to prove that triangle APS is similar to triangle BRS. So one person is asking, how do you actually prove similarity? Okay, first thing that you need to understand is that in similarity, we're just trying to prove that the corresponding angles of these two triangles are actually the same. The beauty about this question, if they give it to you like this, is the order has already been arranged for you. So you just have to prove that angle A in the first triangle is equal to angle B in the second triangle. You then have to prove that angle P in the first triangle is the same as angle R in the second triangle. And then lastly, you have to prove that angle S in the first triangle is the same as angle S in the third triangle. Now, most learners might make a mistake, like for example, if you're looking at the last pair of angle S and angle S, you might think that angle S is common. So don't make that mistake. If I had a triangle and I had another one that looked like this, such that it is inside the first one, you will see that this angle S would then be a common angle. So this is what could qualify as a common angle, because it means angle S is an angle in the little triangle, and that angle S is also an angle in the big triangle. So in that case, angle S would be common. But be careful, because sometimes you are dealing with a situation such as this one, right? Such that, yes, you do have S, but the first one is angle S1, and the second one is angle S2. So this is not an example of a common angle. You can't say angle S equals to angle S because it's a common angle. It's not a common angle. You'll need more information or better reasons to claim why angle S1 is going to be equal to angle S2. So I'm just saying that out there because it's one of the challenges we have when we have a situation such as this one, where we have S in one triangle and we've got another one in the second triangle. So people just look at that and they think, angle S is common. So be careful of that. The second thing I want to say, beyond what we said so far about these angles being arranged in the right order, is you don't really have to prove all three. If you can just find two, then we're done. If two pairs are equal, then the third pair is automatically going to also be correct or equal. So your job is to check if the first pair is equal. If the first pair is equal, go check the second pair. If you don't see reasons why the second pair is not equal, jump to the third one. So if it comes out that the first pair is equal for a particular reason, and the last pair is also equal for whatever reason, then the middle pairs will also have to be equal as well. So just find any two pairs that are equal, then you'll have succeeded to prove that those two triangles are similar. So let's have fun. How do you do this? Okay, 1, 2, 3. You need 3 relationships of these angles being equal. Let's go to the triangles and see why those are going to be equal to each other. Triangle APS, they are similar actually. Where's APS? So A is here, P is over there, and S is going to be there. So if you have highlighters, it helps because you can then highlight the triangle of interest and see what is going on. The second triangle that we want to talk about is going to be triangle BRS. Okay, let's find BRS. You see what I meant. So B is here, R is over there, and S is going to be over there. So do you see what I meant? You can't claim that angle S is common because one angle S is in the yellow triangle, the other angle S is in the green triangle, and that's not a common angle. That's in two different places, so just be careful of that. So we're trying to prove that these two triangles are the same. They don't have to be the same in size, but they're just identical in the sense that they are similar. Okay, so let's find the reasons why angle A will be equal to angle B. Why is angle A in the first triangle equal to angle B in the second triangle? Well, you will see that in the first triangle, we've got that box for 90. And in the second triangle, we also have that box for 90. So those are equal because they are equal to 90 degrees, and we were told this information. So angle A in the first triangle is equal to angle B in the second triangle. You can say B2 if you want, but you don't have to because we already see the triangles that you're talking about. They're both equal to 90 degrees, and this information was given to us by very, very kind examiners. Second part is I'm trying to prove the second pair. Why is P equal to R? Let's look at P and R. P in the first triangle is actually equal to angle P4. R in the second triangle is actually equal to angle R1. Now you'll see that the relationship that exists here is what we call the tan-chord relationship. There's a tangent, there's a chord, and then there's an angle right there. The angle between the tangent and the chord is this angle here, which happens to be the P4 we want. And the angle that is subtended by that chord that leads us to S from P takes us straight to angle R, which is angle R1. So that tan-chord relationship exists in that particular pair. So what I'm going to say here is angle P4 equals to angle R1, and the relationship is going to be tan-chord. Okay, so angle P4 equals to angle R1, and the reason is because of tan-chord. Like we said, we don't have to prove the third one. You can just be nice and say, so the angle S in the first triangle, what are they? It's S1 and S3. S1 and S3. S1 is equals to angle S3, and the reason is because of sum of angles in a triangle add up to 180. So if two pairs are equal between two triangles, the third pair is always going to automatically be equal because they need to sum up to 180 degrees. The next question is saying you have to now find the product between AP and RS and show that that is going to be the same as BR times PS. Now, if you stopped your similarity where we are, you didn't answer the question. Why? Because you need to conclude and say triangle APS is similar to triangle BRS, and the reason is going to be angle, angle, angle. Why is this result important? Well, first of all, they asked us to prove it. You can't prove without conclusion. Secondly, once you've got those similar triangles, grade 12s, you can immediately start building the following proportion. You can then say this side, AP, let's put it in a different color so that it stands out. If you say AP divided by BR, you'll get the same result as PS divided by RS, and it's going to be the same result as the last one, which is, you'll see there, AS divided by BR. And this is because you've got similar triangles. So this relationship that we have here of these ratios is the one that is actually very important. It's the one that you need, because for you to answer the next question, that is definitely what you need as your opening line. You need that ratio to come here as your opening statement, and you can see we're taking it from that very, very, very proof we have above. Once you've proved similarity in your question, you then can be able to claim this similarity that you have here. Don't forget that the reason needs to also tag along and be part of what you want to achieve. Now, after this, you identify which pairs are interesting for us here. We want a pair that has got AP on it, or the ratio that has got AP on it, and that ratio will obviously be the first one. And then we want the ratio that also has RS on it, okay, RS, that's going to be the second one. So we just have to compare those two. You can't compare all three at the same time. Focus on two of them. And when you cross multiply, you'll see that you end up with indeed AP multiplied by RS equals to BR multiplied by PS, okay? And that is the proof of that question. The last question for today's program is we are required to prove that angle P4 is equal to angle R2. Now, I want you to think about the following. It is always complicated to prove these kinds of non-numerical questions. The best advice I'll give to you is take one of them, go back to the drawing and just call it X to make your life easy. I don't know if your brain is able to make the connection, but for me, I always struggle if I must prove that P1 equals to T2, but T2 equals to Z19 and Z19 equals to R13. Like that train of thought is too much for a lot of learners. So my advice to you is, even though we don't have much time to try and find that relationship of proving that indeed P4 is equal to the value of R2, we just want to prove that. I'm just going to call one of them X. I'm going to call this one to be equal to X. If you call this one X and you want to prove that P4 equals to angle R2, once you let this one be X, your job is just to find all the other angles in the drawing that are equal to X until you get to a point that this one also becomes X. So your job is just to show that this angle over here is going to be equal to X. So what you do is just play around with all the numbers that you can to be X's. If this line is a diameter, obviously this is going to be 90 degrees because this is the angle subtended by a diameter. If this angle is X here, who else is going to be X? I'm just going to keep writing the X's here. I think you guys will be able to pick this up and put the reasons. That is going to be X via tan chord. Once you have that, you can do more in terms of finding all the other angles. There's a lot of things that you can do, like this angle here is going to be 90 degrees minus X. Okay, once you've got that, you've got a lot of things that you can actually be able to work out with if you're trying to figure out what the answers are going to be. Obviously, this is also going to be 90 degrees minus X, right? So you can be able to just continue playing around. And then if that is 90 degrees minus X, we can be able to see that the angle that you have in that corner has to be the same as this one that you have over here. And if you are dealing with what we have, you can also be able to move your way until you get to a position where you work out the value of that. Remember, like we said, we want to prove that the angle R2 is also going to be equal to X. And if you are dealing with what we have over here, you can just play around with all these X's, find the values of what you're looking at here. Everything else is going to work out fine because this is also going to be the sum of the angles in that particular triangle. You'll be able to work out what the answer is going to be. But the goal is eventually to try and move your way by finding all these other angles until the other one also becomes X. So that's how you approach those non-numerical questions. Because of time, we won't be able to finish it off on a show that is proudly brought to you by Liberty. A big shout out to Liberty, a big shout out to our production team, and also to you for joining us. We'll meet again next time from me. Bye-bye.